Hey guys, it's a pleasure to meet everyone. So whether you have a person behind a wheel of a vehicle or autonomous vehicle, maintenance is still your biggest issue. And especially for autonomous vehicles, how does that vehicle know it needs service? Who is checking if that vehicle needs service and who is actually coordinating that vehicle for service, right? That's where RoboTire comes in. Next slide, please. So you don't have to play the video, you guys can watch it later. But what if there was a scenario where your vehicle, say this autonomous vehicle, could get turned into repair mode? It drove itself to a repair center, got fixed, and was back in your driveway before you woke up in the morning. And everything was taken care of, ordering, scheduling, payment, just like a one-click Amazon. That's what we're going after. And we approach that in three ways. Next slide, please. The first is creating a network of robotic repair shops across the US. Currently, we have one system live, and we'll be deploying 100 of these by next year alone. Our current platform handles, as our name, tires. So we do tire changes, tire rotation, and full assembly swaps. I'll get into the tech a little later, but we can do a set of 4 tires in under 15 minutes from pull in to pull out. We'll eventually bring in underbody scans for dents, stings, rust, alignment checks, suspension check, brake checks, and outer body scans so we can create a whole platform for vehicle maintenance. Next slide, please. The second step is we don't even have to wait for the car to be completely autonomous to actually start this process. And we do that by integrating a real-time tread depth monitoring sensor into the tires so that they're actually talking to RoboTire. So we can then predict when tires need to come, which is highly important for fleet managers. Meaning if they have a fleet of vehicles and the one vehicle is not due to come back for another month, but we're currently measuring 5/16 on the tread depth, we would then prompt the user to then come and bring that vehicle in because we know when that vehicle comes back, it will be under the legal limit. Next slide. Then this is the holy grail, right? What we just talked about of the vehicle talking to our robotic system to then understand its status of health and communicating all of that information. And RoboTire is actually the one predicting when that vehicle comes in, scheduling it because it knows its mission or path to do. And we're already developing this technology with the Army through their RCV view. Next slide. So again, the efficiency, right? The powerhouse of RoboTire is that we're using robots to automate the tire changing process. And like I said, we can do 15 minutes for a set of 4 tires from pull in to pull out. If it's full assemblies, we're sub 5 minutes, almost like a pit crew for fleet management. We alleviate a lot of the labor shortages, the pains, and the vast amount of data that we're collecting that is normally not collected by a human. Next slide, please. So again, like I said, our data is the key for this. We're actually an open API. We can connect either to a car, sensor, shop. It doesn't really matter. And we use computer vision to understand every aspect of that vehicle. And the beauty is that the network of robots. So that means if we make an update, it gets pushed to all the robots instantaneously. Same goes if we add a new bolt pattern or a new feature set, all these robots can learn and adapt by themselves and teach each other. Next slide, please. So again, like I said, there's a changing in the way we deliver stuff. So fleets and micromobility is coming really hard, plus the electrification of vehicles. And what all this means is we're just going to go through tires a whole bunch faster. And as soon as you go electric, gas is no longer the number one maintenance cost for that vehicle. Tires is now the big one because tires is sitting at number 2. So we've drastically reduced cost per mile and increase the uptime of that vehicle so things get delivered faster and cheaper. And like I said, our APIs are already talking to cars, sensors, and so on. Next slide. And this is just an overall layout of what we'd install in a service bay. Again, you have 2 robots. If you watch that video at a later date, you can see our robots currently in action, removing tires and all of that. Last slide, please. Again, this is just a quick overview again of RoboTire, where we are right now. We have a bunch of algorithms built around, how to predict maintenance on a vehicle, not only to tires, but other aspects. We are going live and accelerating with some of the key marquee players in this industry. And we're utilizing the Army and Air Force contracts to basically harden and develop our system for larger format vehicles. And we have a 140,000 square foot manufacturing facility here in Detroit, Michigan, at the heart of the automotive world to build these robots. Last slide. Now it is the last slide. Thank you.
Thank you very much, Victor. Opening up the floor for questions. Go ahead, Ilona.
Hi, Victor. I've been looking at flight line autonomy. I'm curious if one of your use cases would be aviation aircraft tires. Have you looked at that?
Yes, we actually currently have a AFWERX contract to deploy this at Travis Air Force Base. We're handling most of the vehicles on the runway, but we are also in talks of a C5 to change it for aircraft tires. High level to us, for us to train a model, so a bolt's a bolt to us, and a tire is a tire for us, whether it's on an aircraft or vehicle, it takes us 15 minutes to train a new model and for the robot to understand all the parameters and everything about the tire. So it's very quick for us to develop into new verticals for this.
Victor, nice presentation. I've watched you before in previous presentations. You've actually come quite a long way in the last 8 months or so since I saw the first one. Question for you on the applications. You mentioned commercial aircraft. Are you looking at commercial vehicles? Because one of the areas that we were researching and do for logistics back at Panasonic was the UPS was looking for ways to change out their tires and then also do research on their tread patterns. They wanted to figure out basically the driver efficiency using the tread. I just wondering if you are able to capture data on the tread wear and also if you can form factor a larger wheelbase like a truck or a step van.
Yes, we are moving heavily into fleet. That's kind of our next big push. Right now, we cover every vehicle smaller than an F-250 right now. That's just our baseline. Later this year, we'll actually bring out a system to do big rigs. So we'll cover everything from a Prius all the way to a Class A vehicle. So we tap into that fleet. There's a lot of stuff we're doing with a few of the gig economy providers and a few others that I can't really mention at this time. But to your point of being able to use predictive analytics to understand driver and road condition and then environmental conditions. So how's the tire reacting in Maine in the dead of winter versus Arizona in the summer, right? That's all going to affect your wear, tread, and also then do a better job because most fleets don't really rotate their tires. So being able to maximize life out of a tire, especially for a fleet that is, some fleets are do 4 tire changes a year, right? So there's a high volume of tires being changed. So yes, we're building all that in the back end as well.